Okay, thank you, Mark. So I suggest that we start with the echo session of today. So first of all, welcome to all of you who have joined in to discover or rediscover, if you've already seen presentations about echo earlier, to discover what we're doing and why we're doing what we're doing, and to see already some of the results. That's our main purpose of today, to show a little bit where we're going and to show you what we have already done during this first almost half of the project. So I'll immediately start. Voila. So we started with the EU cybersecurity challenge, as it has already been discussed yesterday in the panel meeting, and earlier. It's the problem that we know we have a lot of internal overlap between different activities. There is sometimes an unnecessary internal competition, and so it's better to be united. However, united is one thing. Diversity is a good thing as well. If you have diverse cultural perspectives, this can certainly inspire creativity and drive innovation, and we see that in ECHO, certainly, that the very rich discussions we have regularly between different people with different backgrounds and different skills, that it creates for a very rich discussion that allows us to move forward in what we think is the best possible way for the project. Now, what was discussed yesterday as well, and that's, I guess, the starting point of all of our activities in the pilots, is to strive for European strategic autonomy. It's a very important goal that we want to achieve, and strategic autonomy means that we have the capacity to act in 4 dimensions: politically, institutional, capabilities, and industrial. Now, when we translated that to what it means for us specifically for the project in terms of strategic autonomy in cyberspace, for cybersecurity, it means that we need a solution that is sustainable. And so that means that we need a governance model. And in terms of the governance model, we have a very active group within ECHO that is working on possible governance models, that has compared what exists and is developing, and has already proposed solutions for the future governance model of the network. And we are also adopting it inside ECHO. We are moving towards that governance model as an internal way of managing the project. And we're providing bottom-up input to the decision makers. And we're actively collaborating in the interpilot focus group on governance as well, as you will see when that focus group presents their work. Now, we don't just connect. When we want to build that network, we really want to build network communities around specific topics of interest, where there is really a need and a willingness to exchange information and work together. And I will show later on in the presentation some examples of that around everything which is threat intelligence, early warning, around cyber range-based skills development and training. And we really think that you should not just grow for the purpose of growing, but grow in a very targeted way in order to build those communities of the future that will be interconnected through the network of cyber competence centers. Now, a second thing about strategic autonomy is that it's technology driven. We know that within Europe we have recognized scientific excellence. I think we can say that. But what is still missing is the transition into a European trusted supply chain of industrialized solutions coming out of that scientific research. Now, technology driven, we know that technology in itself is not changing the world. It's the integration of technology and society that is. And it's in the end users, the consumers, that by adopting specific technologies are the driving factor of which technologies are to be successful and which will slowly disappear. And so it's in the end user that is the kingmaker. And that's why we really need to listen to what the real needs are and really assess what is needed by industry, by the different sectors, by the end users. And I'll come back to that later on in our presentation, that we really try to to look at what the real needs are and guide all of our developments using what comes out of that assessment. Now, the final thing is capability driven. Autonomy means that we can assess a situation, can make decisions, and then have the freedom to act in order to execute those decisions. Now, making decisions means that we need situation awareness. We need to be able to understand the situation, to perceive, comprehend a situation, and then project into the future what possible decisions might have as an effect, so we can take the best possible decision. And so we really need at the European level tools for building that situation awareness at all levels, whether it's at the level of the individual, the organization, a sector, or at the European level. And we need to have the necessary skills in our workforce in order to be able to build up that situation awareness and to make the right decisions. And so situation awareness will be something that we will be talking about a lot in our ECHO session today, because the tools that we will be presenting today happen to really have as an ambition to contribute to that situation awareness. Now, when we looked at the start of the project, what are the challenges we see for cybersecurity in Europe? And you can see them on the slide. We identified that there was really a need to do a multi-sector assessment of what are the real requirements. So not just do what we think is good, but really start from a rigorous scientific assessment of what the real needs are in order to satisfy the needs of different sectors. Also, in order to build situation awareness and have the necessary skills and have certified solutions, we really need simulation environments, read cyber ranges, that allow us to do this type of very extensive, very complex scenario simulation in order to build the necessary trainings and to really evaluate the usefulness of tools to build, for instance, situation awareness, but also to contribute to cybersecurity. So we really need, we identified the need for more complex simulation solutions than that was available at the time with the cyber ranges that existed. And as we will present later, it's really something we're working very hard on, where we are really going towards federation of cyber ranges, where we can integrate into a federation multiple cyber ranges that have specific simulation capacities of specific technologies in order to be able to simulate much more complex environments and much more complex realistic scenarios than what was possible before. Also, what is needed is a cyber skills framework. In the end, it's, as was also said yesterday, it's all about the people. It's about the people who need to operate this equipment, to use it, to put it in place, to design solutions that are secure by design, and also to manage cybersecurity related crises. So we need this cyber skills framework, and then the necessary trainings in order to satisfy the needs to train the people to achieve this knowledge, these skills, and these abilities. And then finally, the means to share knowledge, to share threat intelligence, to share situational awareness in order to have this joint situation awareness. So those were the challenges, and out of that came the ECHO project. And we started working with a large number of partners to achieve our objectives. And so one of the objectives is to grow that network of cyber research and competence centers, engage new partners, and on the other hand, it's to develop these solutions that answer the needs for building situation awareness, for creating strategic autonomy, and to answer the needs that were identified from our multi-sector assessment. And so these are the people working on all of these topics. As you can see, it's a very rich group of industry, academia, research centers. And we divided the work in a number of different activities that you can see here. These are more or less the work packages that you can find within ECHO. So we have a big activity in the work package on governance, where we are building governance models, and this will be presented in more detail when the focus group on governance will present their work. And the second one is an activity on the multi-sector assessment framework. And as I've already mentioned before, ECHO does not just talk. ECHO also listens. We try to listen more than we talk, because nobody learned anything by hearing themselves talk. And so the listening is translated into this multi-sector assessment framework, where we really try to assess the needs, and from that we develop technology research and development roadmaps. And those will really guide our work, so that what we do is really guided by the real needs of the people and of the industry. The next work package is on cyber skills framework and training curriculum. We have another work package on other activities, another work package and activity on a security certification scheme. We have an activity on the federated cyber range, and we have an activity on the early warning system. And those two, the last two, we will look into in much more detail today in the presentations that will follow. Voilà. So here you can see some more information about the technology roadmaps. I'm trying to zoom in a little bit. So the whole goal of our multi-sector assessment is that whatever we do within ECHO is guided by an identification of what the real needs are. And so we started with developing a rigorous, scientifically sound approach of how to identify those needs, and how to do that multi-sector assessment that allows us to identify transversal and cross-sector opportunities, and translate that into roadmaps, and finally translate that into demonstration cases that we're working on. And the demonstration cases will also be presented at the end of our session today. One of those technology roadmaps that we identified is the need for an early warning system. It's the need for being able to exchange threat intelligence, but also exchange information during an incident, during the handling of an incident. So it's about the tickets, incident tickets. It's about translating what has already been seen into early warnings in order to spread the information through the network, and to derive knowledge from that, and to derive threat intelligence at higher levels. So rather than just aiming at exchanging low-level tactical or technical threat intelligence, we really want to reach higher into higher levels of abstraction related to threat intelligence, and really go into early warning information that allows us to better protect our critical systems, well, all of our systems, against cybersecurity threats, and to share information related to that as efficiently and as quickly as possible. So here you can see the different types of exchanges that we see. So we really recognize the importance of checking my time. Yeah, we really recognize the importance of exchanging threat intelligence and early warning information, because in the end, the decisions that you make depend on your situation awareness, depend on the information that you have, on the comprehension that you can make out of that information, and on the capability to project what future actions will be of the opponent, and what the impact will be of your own actions. And therefore, you need to be able to exchange based on trust relationships. And it needs to be, for instance, within a sector, within a country, but also cross-border at the European level, in order to be able to protect ourselves as efficiently as possible. It was mentioned yesterday as well that ENISA already produces these threat landscape reports that are very interesting, but that's not enough. We really need to go forward, and we really need to share on a day-to-day basis operationally threat intelligence within Europe, in order to protect ourselves all together as good as we can, and share all the information that we can share in a trusted way between the different stakeholders. And that's one of our developments. It's the early warning system that aims at facilitating that exchange. Then, and you will have a full video that will explain a little bit on how the system works and how far we have gotten in terms of our prototype that implements that early warning system, and the tests we've already been doing to validate the system and to guide us as we go along. Then
time is running. Sorry if I interrupt you.
Yeah, and so the second technology roadmap that we are already very actively working on, that we will show off today as well, it's on the federated cyber ranges. And so it's about, first of all, a technological challenge on how to interconnect these cyber ranges, but also a way of how we can make this capacity available through a marketplace. And that also will be presented in the video that will be shown later in our session. Here you can see a little bit of a drawing of how technically we realize it. It's with the use of VPN interconnections between the different cyber ranges to interconnect them at the technical level. And then there is a whole mechanism for expressing capabilities of the different cyber ranges and matching needs with capabilities. But that will be shown during the video as well. Here you can see some of the outcomes. So we have the FCR, the EWS. We have the different activities on cyber skills. But since time is running out, I'll go a little bit more quickly. I have a few more slides left. So we already have some active services running as well, where we actively distribute information related to cybersecurity that we collect, and through a daily bulletin and newsletter that we collect, and you can find that information on our website. We also invite you, of course, to join us if one of these activities is of interest to you and you want to participate in the testing, in the validation, or in the development, or just want to be informed about what is going on. Do join us. You will find all the information on the website. And with that, I pass the floor to Matteo to introduce the two videos and finally the demonstration cases.
Thanks, Wim. So I'm taking the role of presenter and I'm sharing a video. My recommendation is to change the quality of the video directly from your browser, because you can do it, and put at the maximum quality. So the first video is about the eco early warning system. You should also hear some audio with it.
Early warning system is meant to be used to strengthen the cybersecurity capabilities of Europe. We are building a system where we safely can exchange information, coordinate incident response, and support the ECHO network. The goal is to be able to, in timely manner, respond to high incidents, share knowledge and warnings, and to become more proactive before the incident happens. ECHO network will leverage AWS to enforce trust and collaboration among the organization. Let's imagine a global crisis across the European Union, just to allow a first glance at the AWS capabilities. How can AWS support cyber defense situation awareness, covering perception, comprehension, and projection level? First step can be the notification of an early warning within the ECHO network regarding the crisis attacks ongoing, followed by trusted exchange of knowledge base, tactics, techniques, procedure or mitigation. At some point, a collaborative incident response will be necessary by sharing tickets, performing a continuous analysis by dashboards customizable according to the organization needs, domain, or sector. To build the AWS Federation, it's important, obviously, that each organization can control the data flow. That is possible to control participants of the federation and that the information exchange is secure. To satisfy these requirements, we opted for a deployment where AWS can operate in a multi-tenant mode, allowing several organizations to belong to a shared instance, or in a fully distributed mode, allowing organizations to operate their own instance. On the screen, you can see two browsers connected to different instances of AWS. Federation management is TLS certificates. The trust of federation is given by the root certificate, which is used to sign server and client certificates. In this way, we can control whom give the possibility to join the federation. The server certificate is used to prove to the other instances also connected to the federation that we are part of it, while the client certificate is used to provide the trust on the client connecting to us. Each instance who wish to join the federation must perform similar steps. After that, I have also to establish connection to the different nodes. In each instance, I will add the other nodes with which I want to establish a connection. This is performed by importing the client public certificate from the other nodes. As soon as I create a node, there is an handshake between the two different nodes. Here the connection status is already connected. I'm now creating an organization in the last instance. As soon as I save it, it will immediately be synchronized over the other instance. The blue icon means that there is a local organization, while the red icon means that it is an imported organization residing in a different node. Organization can later be included in constituent that will give the possibility to exchange information among them. An ecosystem of plugins has been developed. The plugin offers some additional capabilities to AWS. For instance, collection of unstructured text data from social media accounts, surface, and dark web, interfaces to external vulnerability scanner, automated security privacy controls over AWS data, correlation of information from multiple TISPs to provide users with a better view of the threat landscape, representation of cyber threat intelligence by views and graphs, cyber threat maps, CV prediction model, and so on. AWS has been conceived to interface external plugins and systems. In order to allow AWS to be extended and allow for integrations such as external ticketing system, network monitoring, visualization, data importers, we decided to build an interface that would allow us to both react to new data inside the system and to allow to query and modify the data contained in AWS. The system basically allows an integration to subscribe to different events through the plugin management. When the events happen, the system will inform any external system by sending a webhook when the event has occurred. It's also possible to provide data to the system through a REST interface. We have developed a set of data transport models that allows to query, create, update data in the system. These models are shared in the SDK package, which are used by the different plugins we are interfacing currently. Here I show also how I can update the menu with the link to external systems. I'm now showing some capabilities of AWS by the use of a story which starts with the following question. How can AWS be used in order to protect against an attacker exploiting multiple vulnerabilities in order to achieve a catastrophic failure on critical infrastructure? The demonstration will uncover a set of events leading up to the failure of the power grid. AWS plays the central role by aiding in information exchange and coordination of incident response. The story begins by an independent security researcher who is interested in smart devices. The researcher has laid hands on a modern broad toaster. The particular toaster has the possibility to connect to internet in order to start toasting from remote. The firmware from the toaster is both from a company specialized in IoT devices, which is providing the same or similar firmware across several brands. The researcher files a CVE for the specific vulnerability found. The information about the CVE is imported by AWS by our reference library importer that automatically fetches CVEs directly from the national vulnerabilities databases. AWS has the possibility to handle, for instance, IDF objects, CVEs. These objects can be used to create references to and from incident tickets or warnings. These help us to put different things in a context. I'm going to perform a search for a specific reference object that has been imported. The CVE risk is high, but since the device affected by the CVE is a large consumer device, the patching practices are not easy to enforce or monitor. Therefore, the CVE is largely left unnoticed inside the AWS system. Sometime after the CVE has been imported into the AWS, an unrelated event occurs. Multiple internet providers across Europe have both the same model. Some of them have now recognized increased network traffic that is originating from a single source. This is highly unusual since most network traffic is initiated from the modem and not the other way around. Internally, some organizations are conducting an investigation. An incident ticket has been created. I'm going to display the already ticket shared. This has been shared with the Belgian CERT. The ticket sharing allows us to decide which field of the incident ticket you want to share. Here we can see fields in blue which have been shared. Other information about your organization like internet network addresses has not been shared because you don't want. During this specific incident, we believe that our customer's network has been compromised. We have also observed that the specific file hash that has been uploaded to the different networks. This information is shared inside the ticket. It's later available for reference. Information relevant to other partners can be shared as warning. The difference between ticket and warning is that the warning can be shared much earlier than an incident ticket. Also, the tickets are based on a flexible template model, while warning have a more static type of model. We want to have a model that we could easily understand machine to machine, but also that was coherent between different organizations. We opted for a model where we have a generic part information as a name, distribution, threat level, confidence, description, co-student, and a flexible part information with a tagging system based on mixed taxonomy and different attributes. For instance, we are observing a specific malware. We want to describe this with attributes specific to the malware. The attributes are specified by a triple of information. We have a context in which something is occurring, then a type name which describes the data types inside this specific context, and the direction. For instance, to specify if this is a source organization or a target organization. We are currently working on extending the list of attributes that we would like to record. As a consequence of the previously observed incident, we have here created a warning that instructs different internet service providers to patch their system because we are observing an attack against end users of this specific device. We have recorded an attribute matching the exact CPE of this product, and also we have different references to the other objects. Like the reference to a specific CV, a few months later the aggregation plugin finds a malware being discussed in the dark web. It states that they can target different countries' power grids and potentially even bring entire power grid down. The data aggregator has the possibility to create automatically different wiki articles in the system. Here we can see different information which have been extracted. We have also some files attached that mention of different threads and doing some analysis on what could be the output and the consequences of this kind of attack. Weeks later, a power grid sees a strange user pattern. The power consumption oscillates in a way causing the frequency of the power grid to drop drastically. As a result of the under frequencies, the Belgian power plants has several alerts going off, and a lot of the load is moved as consequences, almost causing the complete disconnection of several nuclear reactors. As a result, there will be a coordinated investigation between multiple organizations. Evidence points to the malware with a specific file hash. This malware exploits a known CV and also seems to be the malware discussed about and found by the data aggregator. Therefore, we can link with the information that we already have in the system. Since different organizations may have access to different data, there may be more information on this specific file hash. Here I'm logged as a Belgian cert. I'm looking for the file hash. And this points me out the attack observed by the internet service provider earlier. This allows us to understand the two goals of the attack on the internet service providers, which allows us to put the power grid attack in a context and maybe even point out the adversary. Finally, several different new incident tickets are created and shared to enforce the collaboration among internet service providers. To contain a malware and also different fallout reports are shared to know what happened and how to protect better next time. We are working on providing better data visualization on our dashboards views by allowing to effectively filter out what is important for any stakeholders that we would like to support with the system. We also providing statistics and visualization of that data. We are also working on providing different correlations to and between warnings. I can conclude mentioning the continuous evaluation and verification of the platform by means of the internal tabletop exercise, where a large number of organizations and co-students are already involved, and which in the future will be also open to external stakeholders organizations. In the next years, the AWS Federation will be built. In fact, several organizations have already shown their interest in playing the tenant role, hosting one of the AWS instances of the future federation. Thank you.
Okay, thanks for listening. I'm changing the video and now with the federated cyber range. And I hope Well, at least the majority of the audience can also hear the sound.
Hello there, welcome to the ECHO Federated Cyber Range. I am Csaba Virag, the head of capacity building at Guardtime. It is my pleasure to give you a small introduction on the concept before giving the floor to Karen, who will demonstrate the current technological capabilities for you. ECHO Federated Cyber Range, or EFCR, aims to provide a seamless cyber range and exercising experience through interconnecting existing and new cyber range capabilities, enabling cyber range service customers only to focus on defining their own needs, without actually the need to understand the technological details how that service can be provided. Our ambitious goal is to provide access to the benefits of complex cyber range solutions as simple as possible, so it can become an everyday tool in developing cyber resilience. To reach this goal, EFCR operates as a broker among cyber ranges, enabling access to complex emulations of sector-specific and unique technologies. EFCR is more than just a marketplace for cyber ranges. It is the one-stop shop of capacity building, from trainings to large-scale multinational exercises. EFCR roadmap is pragmatic. Potential customers and service providers shall be able to easily find each other. Through the service catalog and supporting visualization tools, EFCR takes care of the sales and delivery process details in the background, along with orchestrating the technical necessities seamlessly. If you wish to know more, or you would like to become a part of the EFCR family, please feel free to contact us through ECHO Project's website. And now, I give the floor to the technical demonstration.
Hi, my name is Karl Hansen, and I lead the development of the ECHO Federated Cyber Range. In this demonstration, I will give a brief overview of the marketplace and its current state. EFCR, in short as it is a deep web service without the permissionless access, therefore the service is provided to registered customers only, looking for specific cyber range services. And I'm going to start the demonstration with logging into the system as a customer to show you what kind of features, let's say, the majority of the users would see when logging into the system. So right away, the user is presented with the service catalog, which is a listing of published services in the marketplace. So in this overview, it is presented the name of the service, brief description, and some other details. And going into the service, you can see all kinds of more detailed information. I will go into this a bit later in more details, but let's step back for a second. So going back to the catalog, so currently we only have 4 sample services here, but let's say once there will be many more, it will be rather difficult to go through them one by one. So what we're doing, what we have added here is a means to search by text and filter by category, reachability, and so on, and we will have some other filters there as well. So, and in addition to just seeing the catalog, the customer can also see the customer submitted services to the system, but I will get into the details about this a bit later. So I'm actually going to log out and log in as a provider in order to show you what are the more advanced features of the platform. So again, right away, the user is presented with the service catalog. So we do not discriminate any registered users. So the catalog, published catalog can be seen by anyone, any registered user. Now, in addition to the catalog, provider can see my services, my federations. So federations is the concept of supporting the provision of services across several cyber ranges. So we can manage, create approved federations here with other cyber ranges or content providers. Then cyber ranges. So we can manage, register, monitor our cyber ranges connected to the FCR. And why do we need to connect the cyber ranges? It's because this way we can leverage on the available capabilities of the cyber ranges to build services in the FCR and use the data from the cyber ranges to validate the availability to provide services at customers' requested time. I will go into details about this a bit later. And finally, component details. Now, I'm going into more details to my services, and in this view, I presented all the services that either I have submitted to the system as a single provider or as a federation, or some other federation has submitted them where I am not the prime. So for example, let's say that there is a federation where RIA is prime, GuardTime is subprime, RIA has submitted a service. I can see this in this my services list. But like this, for example, this service is a federated service that GuardTime is not leading. So, but let's see how it all comes together. So the service, after clicking on create service, the service creation form is opened, where the overview details of the service can be submitted, like the name, the aim, the category, domain, and so on. And basically choosing the category opens up another set of fields that are this category specific. So for example, all our examples are based on training category. So what else we have here? Domain, sector, and pricing, duration, and so on. Then in the scenarios tab, we can provide more details about the scenario of the training service, for example, training or any other type of service. We can add a team. Currently we have limited to one, but we will make this a bit more dynamic. And below here, we have the capabilities that have been taken from my cyber range. So these are the technical capabilities. Then we have the settings, which are basically some metadata. And finally, we can attach files to the service. So I'm going to show you how this service is then submitted to the catalog, but I'm not going to do this by hand. I'm actually going to use import functionality, which is quite a nifty feature, filling up all the fields magically. Now, one more thing I need to do is that at the top here, I have the choice to choose between current service provider and a federation. So I'm going to submit this service as a federation. And in this list, only these federations are displayed where I, as a provider, am the prime. So I'm going to choose RIA and GT Federation. I'm going into the scenario tab as well. And below here, I'm going to choose all of these capabilities for this service. So later on, when somebody submits a request for this service, then validation against these capabilities is made, but a bit about that a bit later. And now let's click publish. So let's jump to the catalog. We see that, okay, this service has indeed been submitted. And in order to actually submit the service request, I need to log out and log in with the customer. Having logged into the system with the customer again, I'm able to see the service that has been submitted to the catalog by the service provider. And upon opening the service, I'm displayed all the details of the service that the provider entered to the portal. So it's the overview and the service description. In order to purchase the service, what I need to do now is I have to submit a service request for this. First of all, I need to set a name for this service. Let's say it's training for my team. So the name is only relevant for me. I want to have this service on the 14th of December. I have 5 participants who want to include it in the training, and I submit the request. In the background, the service validation process is initiated, verifying that the provider's cyber range, or more specifically the capabilities of the cyber range, are available on the given date to provide me the requested service. So let's see in my request view what happens. I see that, very good, my service has been validated. It means that the RIA and GuardTime Federation can provide me this service on the given date for the number of people. In this view, we can start now the negotiation between the customer and the provider. But first of all, I'm actually going to jump out from the customer's view and going into the provider's view, because before the negotiation can happen, the provider would need to provide a quote. So let's first of all send a quote. Let's say first quote and let's say it's 5,000 euros for this service. I'll click send, and now let's log out and go back to the customer's view. And the customer's view, I can see that, okay, nice. I've been provided this quote. I can reject it, I can accept it. Let's say in this case, I accept the quote, and let's say thank you as well. And this message is then transferred to the provider's dashboard. So far, we have concentrated mainly on the features for building a service for a marketplace. However, the EFCR shall also support signing of the contract and the management of the payments through the portal. Once a contract has been signed between the two parties and payments have been approved, it is the service provider's responsibility to take over, brief the customer, and provide the service at the requested date. The service itself is not provided through the EFCR portal. However, having the cyber ranges connected provides us the possibility to collect several metrics about the quality of the service, and these metrics can be used to give suggestions to the next customers. And this concludes my demonstration. Thank you, and have a nice day.
Okay, that's my understanding that someone will load the presentation, the final presentation, or shall I do it? Mark? Oh, okay, thanks. Thank you very much. I'm presenter, so I should be good. I assume that you can see the screen. I'm going to do a little bit faster than expected because we have some time constraints here, which makes sense. So why the demonstration cases? So I hope that what we were able to express to you is the fact that ECO is really developing products, and that's what we want to do. We are also active in prototypes and so forth, but generally everything that we do wants to be at industrial level, wants to be used in real life. And also the development approach that we took for the FCR AWS is industrial life, pipelines, DevOps, and so forth. It's quite serious. When we talk about the ECO assets which have been introduced by Wim before, we are talking about the ECO multi-sector assessment framework, the federated cyber range, the cyber skill framework, the early warning system, and the certification scheme. Everything governed while we transition to the new governance model by the governance model. So each of these main assets needs to be validated following a proper system engineering life cycle of development, verification, and validation, serious validation. And that's why we decided, since from the proposal, to concentrate our validation activities into 5 demonstration cases. When we talk about the ECO demonstration cases, you don't have to imagine something that can happen in one day. Some of them will last for months. Some of them we already started implementing. The demonstration cases are studied in order to demonstrate more than one ECO product, ECO asset at the same time. For example, the demonstration case for cyber skill education and training, the usage of the federated cyber range for cyber skill education and training is leveraging on the ECO federated cyber range, on the ECO cyber skill framework at the same time, and on a set of ECO cyber ranges connected via the federated cyber range. The scenarios for the demonstration cases are taken from our sector and multi-sector scenario analysis in energy, healthcare, and maritime. So we have a huge set of scenarios which we are going to replicate into, in some cases, tabletop exercises, mainly for the early warning system. In some other cases, in 1, 2, 5, 10 of our cyber ranges. So the idea behind the validation of ECHO is really to try to use the tools that we are developing together in order to provide benefits for the community. And in general, I don't want to spend time on this slide, but this is the idea of the complexity of the interconnection of the single tools with the demonstration cases. And even if we have more than 2 years to finish the project, we are already working on that. Also because the maturity of the assets is quite high. Very briefly, as I was saying, the demonstration cases are using multiple tools and they are focused on different sectors and also intersector scenarios. Considering, for example, energy, we are working with our partner Acea to build a complex cyber range emulation environment of a command and control network of the energy provider. With our healthcare partners, we are working on, in reality, we already have a full emulation of blood sample analysis laboratory, and also we are going to build an emulation of a set of medical devices and the network that is connecting medical devices on a cyber range. It's an activity that is ongoing. We are going to use these ranges in order to implement some of the demonstration cases that I was mentioning before. And for maritime, with agreement with our partners, Naval Group and Fincantieri, we are building 2 cyber ranges simulating 2 scenarios in cyber ranges simulating the navigation part of a ship, because in this way we can also emulate intersector scenarios with the space and satellite GPS and so forth. So all these activities are ongoing. In general, as a conclusion about ECHO, 2019 and 20 were really full of development activity, also research, but also a lot of development activity. 2021 will see the finish of the bulk of the development activities, excluding a list of 10 prototypes solving technology roadmaps that we identified. So it's not only about the federated cyber range and the early warning system, but we are also developing 10 different prototypes solving different challenges in cybersecurity. And in 2021 and then 2022, we are really going to validate what we are doing and hopefully also to use it in real life. And please contact us. We are almost everywhere, and we will be very happy to answer to any comment or suggestion or whatever. Thanks.